Okay, here's an equation. It's the base 3 logarithm of x squared and the logarithm of x squared minus 2 equals the logarithm of 7 plus 2. Okay, what is the first thing to do? When we solve this equation, or any equation, we look at the domain. For what possible x values does this make sense? Okay, well, it's like, the logarithm function is not defined for anything which is negative or 0. So it's only positive values. So these are the conditions. X squared has to be strictly greater than 0. Well, that's not too difficult because what is x squared? One can imagine quickly. Oh, that's just a parabola. So that's always greater than 0 except at this point. Okay, so x cannot be 0. So from this one, well, we know that x cannot be 0. Right? But there is another one here. So and x squared minus 2 has to be strictly greater than 0. So x squared has to be strictly greater than 2. That means that x has to be greater than the square root of 2, or x should be smaller than negative square root of 2. Well, okay, that's just solving this inequality. So these two together, so this would be the set, is that all real numbers except 0, and this one, so we need to take the intersection with okay, this one is the union of these two. Okay, and this happens to be a subset of that one because 0 is not included anyway. Therefore, we conclude that the domain is just that. Okay, if you want to be more visual, well then you can draw this diagram. Okay, so these are the possible solutions for this equation. Okay, these are not the solutions yet, but if we get something from here, then we know, that's not a solution. Okay, so we did the domain. Right, so let's go and look at this equation. Well, it's it's fairly complicated, but we know that when we have the logarithms involved, then the best thing to do is just to apply the laws of logarithms, and that can simplify things a little bit. Okay, so let's try to do that. Well, luckily one law applies here because that's the sum of two logarithms, so therefore I can write it as a single logarithm, and that will be x squared times x squared minus 2. Okay, and here what can I do? Well, it's the logarithm of 7, well, that's just a number, and I also have just a number, that's 2, but I cannot combine them this way, but I can actually write 2 as the base 3 logarithm of 9, because 9 is 3 to the power 2. If I write it that way, So then I can do 7 times 9, since 2 equals the base 3 logarithm of 3 squared, which is just the base 3 logarithm of 9. Okay? So to summarize, I can write it as the left side, and here is just the base 3 logarithm of 63. So did it help? Well, yes, indeed, because we know that, well, this is first of all simpler. We know that the logarithm function is actually invertible. So, and the other general rule is that we want to get access to x and it's inside the logarithm. Well, then we have to do the opposite. So we can actually take the power, well, raise it to 3 to this. Okay, so that goes in there and it goes in there. So basically what we have is x squared times x squared minus 2 equals 63. So then, well, let's sort of try to rearrange this. So x to the power 4 minus 2 times x squared minus 63 equals 0. So this is, this is not as straightforward to solve, because, well, we have x to the power 4. However, we know this looks like, from the distance, this looks like quadratic. So this is x squared squared minus 2 times, well, x squared minus 63 equals 0. So if I have a new variable u, which is x squared, I basically have u squared minus 2 times u minus 63 equals 0. Okay, well, how to solve this one? You can just use the quadratic formula, or you might see that, well, yeah, 63 is, well, there is a good hint here, it's 7 times 9. So you can sort of figure out that this would be, well, okay, let me continue here. So we have, let me write it down again. So this factorizes as u plus 7 times u minus 9 equals 0. So let's see, so it's negative 63, and we have 7u and that's minus 2 times u there. Okay, so now, yeah, that works out. So we know that u equals negative 7 or u equals 9. So I solved this quadratic, and now I have to remember that, oh, but u equals x squared. So let's try. X squared equals negative 7. Yeah, that's not for no such real number. It would certainly work for complex numbers, but we are not doing complex numbers just now. So the other one is x squared equals 9. Oh, that's nice, because x equals 3 or x equals negative 3. Okay, and this is the x of the original equation. So this is the time we look at the domain again, and it's like, well, 3 is in the domain and negative 3 is in the domain as well. Okay, so well, what we think is that the solution set will be -3 and 3, but it makes sense to check it. And if I look at the original equation, so I have x squared. Oh, x doesn't appear, it's only x squared. Oh, this is nice, because I can check it in one go. So x squared is certainly 9 for both x equals 3 and x equals -3. Okay, so it's enough to check that. So this is the base 3 logarithm of 9 plus the base 3 logarithm of 9 minus 2, and that should equal the base 3 logarithm of 7 plus 2. But hey, that's exactly the case here. This is 2 and this is the 7, and that's indeed, well, addition is commutative, so that's the same. Okay, so that's good, it checks out. So we solve this equation. Okay, it looked very scary, but well, first we fix the domain. Let's see that as the safety belt, not getting any false solutions, and then we use the laws of logarithm, and using the property of the exponential function that it's 1-to-1, so it's invertible. It's actually a bijection, so we can just sort of get rid of the logarithm by taking raising 3 to that power, and after that, well, we have just a it's just an equation with no logarithms, but it happens to be of quadratic type. So we use this trick of introducing a new variable, solving that quadratic, and then, well, we unpacking this box where we put x squared and figure out the solutions for x. We checked against the domain, and that was fine, but just to make sure, we checked it directly by substituting into the original equation. Okay, so that's solving this logarithmic equation.